Okay, the problem. A group of 200 people between the ages of 15 and 45 were surveyed to determine which of three drinks they would most prefer at a restaurant. The group was further categorized according to two age groups, breaking the 15 to 45 down into 15 to 29 and then 30 to 45. And collecting data on these two variables, the frequency table up here on the left, fairly simple to read this table. If you look at the numbers, this was just the collected data on 200 people. 12 indicates that there were 12 out of 200 that were in the younger age group, and these 12 people also preferred milk. 82 were in the younger age group and preferred pop. 14 were in the younger age group and preferred coffee, for a total of 108 people in the younger age group. 5 people in the older age group preferred milk. 58 in that older age group preferred pop, and 29 preferred coffee. 92 in the older age group. The total number of people that preferred milk out of 200 was 17. The total number of people that preferred pop was 140, and the total number of people that preferred coffee was 43. Now, to ask probability questions and maybe use a formula or two to do some calculations, I'm going to go ahead and name these events using capital letters. So the 15 to 29 age group, I let it be Y for the younger age group, O, older, M for milk, P for pop, C for coffee. So I'm going to go ahead and the joint probability table over here on the right, those numbers are just the relative frequencies of the frequency table. In other words, I've divided all the numbers by 200 and turned them into percentages. So if you look back at the frequency table, 12 people were in the younger age group and preferred milk. That's 6%. 12 divided by 200 is 6%. 41% were in the younger age group and preferred pop. 7% preferred coffee, for a total of 54% in the younger age group out of the 200. So we have a frequency table and basically a relative frequency table that the author calls a joint probability table. Now, let's go to part 1 and look at the 7 questions there. Number 1, it says, what is the probability that a person will prefer milk and is in the younger age group? So the probability that a person will prefer milk and is in the younger age group, in other words, 2 events are true about this person. You can think of this as one of the 200 people randomly chosen. What's the chance that they're going to be a younger person and they're going to prefer milk? So that is called intersection, probability of preferring milk and being in the younger age group. That's also called a joint probability, and we can see it over there in the joint probability table, looking in the younger age group row and the milk column. I get 6% or 0.06, which I can write as 6%. Number 2, what is the probability that a person chosen out of the 200 will prefer pop? Well, there were 140 people out of 200 that preferred pop, but looking over the joint probability table, the probability that a person chosen out of the 200 will prefer pop is 70%, 0.70 or 70%. That's called a marginal probability, and if you look at that, it's in the margin. So in the joint probability table, the marginal probabilities are the percentages that are in the margins of that table. The joint probabilities are 2 events combined, or intersection probabilities. Now number 3, what is the probability that a person who prefers milk is between 30 and 45? This one's a little different. This isn't just someone out of 200. It's actually someone that prefers milk. We're given some information about this person that one of the events is already true. This is called a conditional probability. And the way I would write that is you read in the text, We're looking for the probability that they're in the older age group. We're given that they prefer milk. So this is read probability of O given M. We're told that this person is already someone who's preferring milk. So they're not just someone out of 200. They're actually someone out of 17. Let's look for a minute at the frequency table. This person is not just someone out of 200. We're told that they prefer milk. So they're really out of a group, a subset, a smaller group. They're out of a group of 17 people. Now the question is, what's the probability that one of those 17 will be in the older age group? Well, 5 out of 17 were. So just as a relative frequency, 5 divided by 17. And I can calculate that on a calculator as 0.294. So conditional probability is just that. You're given that one of the events is already true, and that reduces the whole space down into a smaller subset. And then you do a calculation on that smaller subset. So 17 people preferred milk, and we're told that this person is one of those 17. 5 out of 17 were older. So what's the chance that this person is older? 5 out of 17. Now, if you remember the formula in the book for conditional probability, it says probability of A given B is equal to the probability of A intersect B divided by the probability of the given event, in this case probability of B. So I'm going to apply that formula to my problem. This is another way we could do it. I just like to look at the relative or the frequency way to illustrate what a conditional probability is. It's not always as clear when you're using the formula, but I could have just used the formula to calculate this. The probability of O given M is the probability of O intersect M divided by the probability of the given event, in this case M. And looking at the joint probability table, the probability of O intersect M, that's 0.025 divided by the probability of M. So this is 0.085. And if I divide these two numbers, I get, of course, the same thing, 0.294. So one way I can just divide a couple frequencies together, and again that illustrates really what a conditional probability is. It's a little easier to see it that way. But on the other hand, we have these formulas, and without having to think too hard, we can just plug into a formula to get the same result. Okay, number 4. Number 4 says, what is the probability that a person between 15 and 29 will prefer pop? Now, look at the first 3 problems there. In the first one, we had a joint probability. Those are 2 events happening at the same time, or intersection. We have a marginal probability. That's a single event. Number 2, we have a single event, or marginal probability. Just asking the probability that one of the events is true. And then in 3, we have a conditional probability. We're actually told that one of the events is already true, and we're asked the probability of the other one. What is number 4? Is it a joint, marginal, or conditional probability? Are we told anything about this person in the problem? Let's read it again. What is the probability that a person between 15 and 29 will prefer pop? Yes, we're told that they're in the younger age group. So that is my given event. This is a conditional probability. Now, what do we ask the probability of concerning this younger person? We're asked the probability that that younger person prefers pop. Well, let's go back up to the frequency table and first of all look at its frequency. If we're told that this person is a younger person, there's someone, not just someone out of 200, but there's someone out of 108. And then we're asked the probability that one of those younger people prefer pop. Well, 82 out of 108 preferred pop. So 82 out of 108 would be a relative frequency, and I could calculate that as 0.759 or 75.9%. So again, the calculation of a conditional probability, or at least understanding it, is not hard. I could go ahead and use the formula. The probability of P given y is equal to the probability of p intersect y divided by the probability of the given event y. And looking at the values in the table, I get 0.41 divided by 0.54. And that, of course, gives me 0.759, the same value. Number 5. What is the probability that a person who prefers coffee is between 15 and 29? Is that a joint probability, a marginal probability, or another conditional probability? Are we told that something about this person, one of the events, is already true? What is the probability that a person who prefers coffee? Yes, we're told that the person prefers coffee. So that's the given event. This is a conditional probability. What are we asked to find the probability for? That they're in the younger age group. Let's go ahead and just use the formula. Probability of y intersects c divided by the probability of c. And that would be 0.07 from the table and divided by 0.215, giving us 0.326. Again, I can always write these as percentages too, which is a more common way to talk about them. Number 6, what is the probability that a person is in the older age group or prefers pop? That's a little different yet. It's not a joint probability. There's a word or there. What is the probability that a person is in the older age group or prefers pop? There's two events going on, so it's not marginal. And actually, we're not told it's an older person. We're not told that the person prefers pop. It says, what is the probability that a person is in the older age group or prefers pop? That's actually a union probability. So, older, union, pop. Probability that they're in the older age group or prefer pop. That's union. Now, what I need there is the addition law. Probability of O plus the probability of P minus the probability of O intersect P. Notice that even unions are combinations of marginal probabilities and intersection probabilities. So our joint probability table is really the basic numbers we need to calculate most probabilities that we'd be interested in. So I'm going to just put the numbers in this, 0.46 plus 0.70 minus 0.29, and then calculating that is 0.87 or 87%. So if I randomly selected someone out of 200, what's the chance that they'll either be in the older age group or that they'll prefer pop, or both? There's an 87% chance that that would be true about that person. Now, number 7, are the events of preferring pop and being in the younger age group independent events? Now, there are 3 formulas in the book to determine whether events are independent or not. One of them is the probability of A given B is equal to the probability of A. That would show that the two events are independent. In other words, the probability of A is not dependent upon whether B happens or not. So, and that's true, then they're independent. In this problem, I've really already got what I need to pretty quickly show that these two events, or determine whether these two events are independent or not. And if I look at the probability of P given Y and compare that to the probability of P, I can see whether they're independent. The probability of P given Y is 0.759. The probability of P is 0.7. So theoretically, these two events are not independent because the probability of P given Y is not the probability of P. In other words, if you know Y is true, it'll affect the probability that the person is going to prefer pop. In other words, there's a connection there. One is influencing the other. So we would say not independent. Okay, well that concludes part 1. What I'd like for you to do is to look at part 2 and see if you can answer those on your own, and then play the flash file for that one to see how you did.